All right, we are live. 48th episode. We are almost getting into the 50th. Huh?
Almost. Holy cow. 2 more to go. 50.
Exactly.
Wow.
We will need to do a party or
Yeah, we're going to have to think about this. Welcome,
How to do
everyone. If you have ideas on what we should do for our 50th episode, I think maybe better put them into chat.
Yeah, on the chat.
Yeah. I didn't even realize that. Wow. You're right.
48. Yeah. And actually, this is the first one that we are transmitting over Twitch. So I'm checking what's going on Twitch. I'm not a real expert on that.
But yeah, I'm not either.
YouTube and Twitch at the same time to see what happens.
All right. Well, I hope it works. I'm not a Twitch expert either. So if anyone in the audience is a Twitch expert, let us know if it's actually transmitting and coming through properly.
All right. So what we're going to talk today, David?
Well, first of all, let's do a quick welcome. I'm David. That's Mark. Wait.
No.
That way. There's Mark over there.
Yes, this is a solo episode. Yeah.
Yeah. It's just us today.
Now we are two.
Yeah. Just us today, and that's all right. I am going to teach you guys how to use. We're going to make use of Datadog today to do a little bit of health diagnostics and appropriately size the hardware so that when you go through the introductory phases, the pilot phases of building out an IoT project, you can start to size out the type of hardware that your workload, your application is going to need. So we'll get into that in a few minutes. I'm going to use Datadog in this example. I have a repo ready to go. Theoretically, though, this could also work using any of the other monitoring agents that are out there, such as Netdata. I think that Splunk might have one now. I'm not sure if they have expanded beyond just logging. Trying to think, there's another... New Relic might have one as well. I'm not sure. So, certainly you can do your homework. I'm going to make use of Datadog. I've used it. It works great. There might be others as well, but so it should be good.
And actually, this is really interesting because we have some developers that join the community and ask, hey, what device should I use for this use case?
Exactly.
Then using a tool like that can help them to understand if that device with that features exactly fits the needs that they have, right?
Exactly correct. We get asked that question quite a bit here at Balena, which is, what hardware should I use? Can you make a recommendation? And obviously there are some pieces of the puzzle that start to narrow down the hardware selection process. Like a very simple example is the workload using computer vision and machine learning? In that case, you probably need a Coral board because of its onboard TPU, or an NVIDIA Jetson device that has the GPU and CUDA cores on it. You could theoretically also use a Raspberry Pi or similar device with something like a Intel Movidius compute stick. But the point is you can start to do some high-level segmentation based on the type of workload you're running. But then beyond that, now let's think about, do I use a Jetson Nano, a Jetson TX2, a Jetson Xavier NX, a Jetson Xavier AGX? How much performance do I really need? And so we get asked that all the time. So I thought, let's take a data-driven approach to this and see if we can come up with some best practices. And that's where Datadog will allow us to do that. So I'm going to use an example application today, the Kerberos project that we've shown on the show previously. We've actually had the maintainer, Cedric, on the show as well. Mark, I don't recall what episode number it is, but
maybe it was about the 15 or...
Yeah, it's been a while. Probably need to have him back. But, so it's just one sample application. Your workload, your application will certainly vary, but this will give us a good idea of the steps of what it takes to do this.
And you have anything on your desk today?
Oh, I got a ton of stuff on my desk. Are you kidding? I came prepared.
Hey, feel free in the chat to say what's on your desk.
Yeah.
Quickly to have enough time, because I want to sit here and learn how to get the health of my fleet of devices.
Yeah, I see Kenna's in chat. Well, Anuj, it is indeed number 15. Mark, I don't know how you do this. I don't know how you always know the exact episode.
Yeah, that's right. It's the 15.
Yeah,
I don't know. I just say that.
Well, I don't know. Anuj says it is. He's usually a trustworthy individual. So, all right, let's switch over to blurry cam.
Well, let's jump to. Hey, no, wait a sec.
What?
Hey, did we call Chris?
Oh, we didn't get Chris.
Yeah, we are getting used to don't call Chris lately.
Yeah, hold on a minute. Give me Chris before I go around the desk here.
And I will do the Christmas version.
Okay.
What's on your desk?
Still funny 4 months later. I mean, it's April and we're still laughing about this. All right.
Absolutely.
So, blurry cam is looking nice and blurry today, I see. Great job, blurry cam. Thank you for that. All right. So obviously, first and foremost, I have cameras on the desk for today. So that means you need to have a horse or a zebra or an elephant or something when you're doing detection. So of course, here's my kid's zebra. But we'll get him out of the way. And what's a bit more interesting is this little cube that I'm going to use today. This is actually a NanoPi Neo 2 device, which one of these boards is in this aluminum cube. The NanoPi Neo 2 is tiny. It is absolutely minuscule. It's an all-winner H5 chip on it. Oops, I'm backwards. Apologize. Let's see if we can get the light to hit it. There it is. So that's the CPU, the SoC. Has Ethernet, USB, and 1 gig of RAM. Compared to this Raspberry Pi, you can see it's really, really small. So I have 2 of these. I have this one bare, and I have this one in its nice aluminum chassis. The Neo 2 is not a device that we actually support. I had to build a custom OS for it, which if you refer back to, come on, blurry cam, what episode was it where we built Balena OS? 3 ago, 2 ago? Come on, blurry cam.
Yeah, should be like 4 or 5 episodes ago. Maybe.
Yeah, 4 or 5 episodes ago. So I had to go through the process of building an OS for it, but that's okay. No big deal. You can always go review that one. I followed the same Yocto build steps. Next to it, of course, is another Raspberry Pi, and this one's already turned on and running, and it's running the workload that we're going to demonstrate today. So let me get these out of the way real quick. I have one last item on my desk that I want to show off. Come on, blurry cam, get it, blurry cam. No, don't fail me. I have a new, extremely blurry balena fin here. I had been without a fin for a while due to some, we'll call it an incident that occurred with a soldering iron and a voltmeter. I can neither confirm nor deny that I was the cause of the death of the previous fin, but I have gotten a new one. I'm back in action, and summer is coming. It's April here. I don't know if it's April for you as well, but here in Phoenix, it's starting to get hot. So we need to start thinking about if this thing has to go back up on my roof for the summer, I've got to do it soon because it will be far too hot to go climbing up there in the near future. Yeah, with flip-flops. It'll be too hot. I'll drop dead if I try to go up there in another month or 2. So we'll have to come up with a project for this fin and get it deployed.
I will show you what to do, I think, with this fin.
Okay. Well, you tell me what to do with it. Hey, now Blurry Cam is focused. There's the Pi on the bottom of it. So, yep, we have a brand new fin ready to be deployed. It needs to be deployed soon because it's getting hot.
All right. So I have a couple of things actually to show.
Okay. Awesome.
I don't have Blurry Cam.
You don't have Blurry Cam? Well, that's better.
No,
Good.
So I have my fin with something that you will know.
Powering that on. Hang on 1 second. I'm powering that one up. Okay. What is that? Okay. Now I can see.
You know, right?
Is RAC. I know that. They've been on the show
it's a
too.
LoRa concentrator. Yeah.
Yep.
So actually, I have been doing a lot of sessions about how to move, LoRaWAN gateways from TTN version 2 to the Things Stack version 3. And I got something interesting on my mailbox, but it's this.
What is that thing? Is that an electrical box?
This is a box actually for an outdoor LoRaWAN gateway. Yeah, or for an outdoor whatever you want to have.
Yeah.
It's an electric box that it's from aluminum. And actually, at some point, it will be available on the balena fin store. So actually, it's prepared inside to have a balena fin. And to, I'm sure that I will start.
Could survive a hurricane or a tornado.
Exactly. And then ready to get the super antenna.
The super antenna. Oh my goodness. You're going to broadcast across the entire continent of Europe with that thing.
Exactly. So I think it's, one of the things that it's important is that I will need to learn about the PoE thing of the fin, because if you have the Wi-Fi doesn't work inside into an aluminum case.
Oh, right.
Because there is it's a Faraday cage. So I will need to start, thinking on how to use PoE, power over Ethernet, to bring, electricity and internet using an Ethernet cable. So looking forward to have an episode devoted to that.
Yeah, AB is asking, can it survive a nuke? It looks like it might be able to. It definitely looks like it could handle a nuclear bomb. And with that antenna, you'll be able to broadcast maybe that LoRa coverage from you in Europe here to me in the US. I mean, that would set some records.
I'm testing now, and I get with this antenna from the room where I am, not outside. I'm getting like 2 kilometers, like a mile and something else.
Yeah, that's awesome.
So not bad. Let's make some. Actually, I got a present from RAC. I got the GPS. This is a WIS block. It's a LoRa node, and I got the GPS. So now I can, we can get some measurements of LoRaWAN connectivity.
Awesome. Simple way. We'll do some testing then. There's a future episode right there.
Absolutely.
I'm laughing these comments.
Maybe let's make a recap of all the comments.
Oh my goodness, a quick recap. All right, hang on. I see iShotJR likes the Christmas version, so we'll play that in his honor on the 15th. All right, no problem there. We've got Lil Uzi Jacuzzi in the audience today. iShotJR episode 17. Wait a minute. Is that in reference to... Because Anush said 15, so now we'll have to determine which one is correct. Let's see. Pretend you see a very crisp image of a balena fin. Yep. Although blurry is best. I don't know. We see... What else? Oh, you put the...
we have as well AB. Explain. Sorry.
Oh, that's all right.
He has on his...
AB's got some stuff on his desk. MPU 6050. I don't know what that is.
Me neither. But actually, the BME 680, maybe it's getting more expensive. So if you sell it on eBay, actually, I checked. No, Bosch is not accepting any order for that hardware anymore. Until they get, so there is a crisis on the hardware for the chip manufacturers.
Yeah, I've heard about that.
That will be more expensive.
All right. Tilt the earth. All right.
On the same continent, right?
Yeah. He's out on the island. He's on the island. So
on the island.
he's on the island. We'll be okay. All right. Well, let's get going on this experiment in data-driven fleet health and device selection. Let me see. So you saw that NanoPi. I plugged it in and brought it online. AB says it's a motion sensor. Okay, good. So let me switch back just for one split second to blurry cam and see if he's still blurry. Oh, he's not too blurry at the moment. I powered this up. I don't have its little built-in LCD or OLED display running, but that's okay. All I have connected to it at the moment is this, if you can see it, come on, Microsoft USB camera. Cool. And I have the same thing connected on this Pi4, another Microsoft identical unit, a LifeCam. I forget the model number, but
this is from your webcam collection.
Yeah, from my collection, yeah. And these are just plain cheap ones. These are not great webcams, but no worries there. All right, so that's pretty much all I have attached. I've got the two devices and the two webcams.
Is this a Wi-Fi dongle on the?
That is a Wi-Fi dongle on the back of the NanoPi. It does not have Wi-Fi built in. But let me grab this URL real quick and put this into chat for everyone. This is the repo I'm going to use today. And here we go, coming in. So this is sitting in our GitHub playground. And like I said before, it's only an example of using an application plus Datadog for the monitoring. Datadog collects the device diagnostics and ships them up to their cloud for log and metric viewing. And I'm going to show that off in just a few moments. One quick note before we get underway is that I'm using Datadog in a container today. In the future, this might become a block. We've spoken a lot about blocks in the past, I don't know, what do you say, Mark? Probably 6
episodes.
Yes. Well, I mean, yeah, we had one devoted to blocks, but I was going to say the past 6 or 8 episodes, we have spoken a lot about blocks. So I'm using the stereotypical traditional container methodology today, but in the future, it might get even easier. So you might be able to just pull it in as a block. We'll see where that goes. But for today, running it as a more traditional container. And like I said at the top of the show, I'm using Datadog. I've got some experience with it and knew that it will do the task that, give me the data that I want. There might be others out there. I have not, admittedly, taken a closer look at some of the other options. If you have other ones that you prefer, the theory and the concept should still apply. So with those warnings, cautions out of the way, let's do this. So first and foremost, Skinner made it appear. So first and foremost, let's take a quick peek at what Datadog is, because I'll start there just to give you a little bit of kind of baseline knowledge to visualize what we're going to be doing. So inside of Datadog, when you are logged in and your container is deployed, and we'll do that in a moment, but once you're logged in, what you're essentially presented with is a dashboard about the metrics coming off of the device. So you can see I have CPU utilization, process memory usage, the load, memory breakdown, swap file if you're using it, disk latency, which in the case of a Pi is the SD card if you're using something like a NUC or something that has a more traditional SSD, or even NVMe or whatever your device is, still your latency will show up in there, and network traffic in bytes per second. So this is all really, really valuable information to have when you're, wait a minute. Is my screen share not on?
No, it's not on.
What just happened? It should have been on. Okay, hold on. Do I need
We
to
already have
double-click?
a question.
Oh, we already have a question. I haven't even shown the screen yet. Hold on a minute.
And it's from Twitch, actually.
Twitch, all right.
Does it affect the performance?
It does have a very, very small overhead. Yes. The testing I've done is that the impact is rather minimal, negligible, not something that I have any concerns with. So the true answer is yes, of course, it is a container, it is running, it is doing a task. Thus, the answer is there is an impact. However, that impact is tiny. There's also two agents that they produce. One is a traditional agent, and here comes the screenshot. This is what I thought I was actually showing. I thought it was presenting.
I was like, wow, he's doing a great introduction.
No, come on, StreamYard. I thought this was running. So there's the traditional agent that was originally designed to run on servers and larger endpoints like PCs and other workstations. Now, however, they produce a smaller, slimmed down version called an IoT agent. And that one has a smaller footprint. That's actually the one I am using today and will show you in the Docker file in just a bit. So here's what I thought I was presenting the first time. We'll go through it again as a recap. So you can see in the dashboard when you're logged in, this is the Pi4, and I'll switch over to the NanoPi in a moment. But you can see CPU usage, memory usage, memory breakdown, swap, disk latency is what I was referring to, and network traffic sending and receiving on the device. Let me actually, you can zoom out. We'll do like past 30 minutes, give us a better perspective. So now also, I might reboot.
Can you configure these dashboards? Or
you can configure all of these. You can make them larger. You can zoom to just specific time frames. So if you need to investigate whether it's an outage or whether it's some kind of an incident that occurred or a change or something in here comes the memory usage. There we go. So you can see I have quite a bit of free memory, and all my other processes can make that a little larger so we can see the Balena engine is running, the agent is running, Kerberos is running. So I just wanted to give this intro as a little bit of context first. Now, having that as a baseline, this is the information that we're collecting. Let's take a step backwards. And AB is asking, can we push custom metrics like data from sensors? Honestly, AB, I'm not sure. I'll have to reach out to the Datadog team, or you can even just tweet at them. I don't know. I will assume that there are ways to pull in custom data. I have to imagine. I know they have APIs to build out, functionality. I haven't done it. I haven't tried it. I feel like the answer is yes, but we should probably have them verify or validate that. So let me. Yeah,
I'm sure you can do, but I think Datadog, it's for infrastructure monitoring.
Yeah.
This is the specialization. I'm sure you can send temperature if you want of your sensor, but not sure if it's the best tool.
Right, exactly. So I'm not entirely sure how to go about it, but we could certainly, research it a bit. So here is this repo that I dropped in to the comments earlier. And it's a sample application just designed to give you an idea of how we go about this, right? So just like any of our other Balena projects, I'm using a Docker Compose, and I'm pulling in.
Can you zoom a bit, please?
Yes.
Microsoft Edge, and it's not possible.
How dare you speak ill of Microsoft Edge? We absolutely have Zoom on Microsoft Edge.
Yeah, one day we will need to create a discussion about the best
The
browser.
best browser. As we've argued about the best editor, we can have a discussion about the best browser next. And the answer is Microsoft Edge. But, so, well, you know what? We'll let the
Full
viewers
stop.
take a vote. Take a vote in the comments. Let's see. So just like any other Balena project, I've got a Docker Compose in here, and I have two containers that I'm building for. The first one is Kerberos. We're going to show that off in just a moment. I'm actually pulling it straight from them. I'm not even building it. Cedric and his team have produced a Docker container that is ready to run. I don't even build it. I'm just pulling it right in from them. The Datadog container, I am building myself. And this is where, like I was saying earlier, in the future, I might not even have to do this. This might just be a block that we pull right in. But for now, I'll show you what I have. So that's the Docker Compose. And then in the Datadog IoT Agent directory is where I've got my Docker file. And it's pretty basic, pretty simple. All I'm doing is taking from my base image using Ubuntu. I could actually slim this down even further, but for testing purposes, I'm using the regular full size. I don't have a separate build and then run. And really, it's just a matter of grabbing their Debian package, putting it into an apt-get repository, and then installing apt-get install the Datadog IoT agent. It is as simple as that. There's a little bit of configuration that we're doing. You can take a look at those files, at your liking, and then just running a quick startup script to start the agent. So it's a very basic project. Again, it's designed just to sort of get you started, get you going, but you can take it and run with it from there. Obviously, they have quite a bit of documentation of their own that I've got the link over to, so you can certainly read through here. You do need an API key. The DD API key is the link that takes a device from Balena Cloud, from the container, from the running endpoint, and essentially tells Datadog, here is the account for which to associate this data. So that's why I have now in my Datadog account, I should actually have a second device. Hold on a moment, refresh that. If that NanoPi Neo booted, oh, it did. All right. So I now have a second device. You click on the device, it's just grabbing the host name. That can be changed. And click on Open in Host Dashboard, and we should be able to inspect the NanoPi now. And yep, this is now.
Wow, what a difference, right?
Yeah, what a difference. So that's what we're going to talk about. So that's what we're going to drill into now. Was this the same tab? No, this was the tab. Let's get this one opened back up as well so we can go side by side. Oh, I already had it in that tab, of course. Go figure. All right. So the point here is this. Now, I have the two devices powered on. They're actually, for the most part, sitting idle. I don't have Kerberos running quite yet. So this is a good baseline. We can compare right away. This is the Pi4. I intentionally chose the 4 gig of RAM model. So you can see in here how much of it, and we can drill in and get, actually, wait a minute. Where is the, is it this one maybe? Yeah, so we can see here. So we can start to drill in and grab specific information about the services that are running and their overall utilization. But just looking at the visual map, the NanoPi Neo, on the other hand, is a 1 gig of RAM device. So it doesn't have much left to give. It's sitting at about a half a gig at the moment, and I haven't even started up the camera yet for Kerberos. So kind of purposefully chose these two different devices to be able to show the discrepancy. All right, coming back, I'm not going to go through the balena push on this today. We've shown that, well, let me see, we've done 48 episodes. Mark, how many do you think we've done the done a balena push on? At least 40 of them, right?
40, 45 for sure.
Yeah, so I'm going to skip that today in the interest of time. But certainly if you watch any of the other 47 episodes, I have a feeling you'll run into a balena push. But the overall concept is using the balena CLI. You can just simply you can git clone this repo, change into that directory, and then do a balena push to your application name. It will package up this Docker Compose, that Datadog directory, send it up to our cloud builders. The cloud builders will run the build, create the containers, and then push the container to your fleet of devices, however many devices are in that application, whether it's 100 or 1,000, doesn't matter. It will distribute that job out, or that workload out, to all of the devices in the fleet. So we've got the container now on the device. Okay, I have my two devices here. Let's switch over to Balena Cloud. Here's my Pi4. I'll grab this one first, because I know that at least I hope that we will not kill this one in the process. The NanoPi Neo, it may die during the next 27 minutes. I can't confirm if it's going to survive. I'm not sure.
What's the device type of this application?
The device type,
it's
so I
Pi
have
3?
It is actually, hang on a minute. My default, well, let's click on add device.
No, it's a generic ARC64.
Yeah, well,
okay.
So the device type, I built this application about 2 months ago, and I was testing at that time on a Pi 3 to see if a Pi 3 was strong enough and performant enough to run Kerberos. And the answer to that was yes. I used Datadog to figure that out. There's a blog post that covers some of that. Mark, if you don't mind, I think I may have forgotten to grab that link. So while you're grabbing that, I used a Pi 3 because I wanted to see if it would run this workload, and found out that the answer was yeah, it absolutely could. So this application was created a few months ago, and I had chosen a Pi 3 64-bit as the default type. Now, with that said, when I added this device, this Pi4 the other day, I just simply came down the list to the Pi4, downloaded the OS, gave it my Wi-Fi credentials, and flashed that SD card. This NanoPi, because, like I said, I had to build this one custom, I was able to choose the generic AArch64 device type, build my OS, flash the SD card, and then inject a config.json file. I don't know if we covered that in detail on the episode a few back when I did a live Yocto build. We do have documentation on that in our docs though, and we could certainly show that in a future episode. But end result is I had an OS and I then hooked it up to my application. Oh. Actually, you know what? I'm already right here. Let's do do I need to zoom this in? I will.
Yeah, I will.
Boot / config.json. Let me make that bigger. And then let's see here if this works. Yeah, so that is essentially all I needed to place into the root file, into the boot partition of this SD card, and that there was enough to then link me through. Now,
Actually, this is a question that I asked you at the end of building your own operating system. No?
Yeah, we were a few minutes over, I think. Yeah.
So that's a good one. Okay.
So let's come back, and I want to come back to the Pi because I want its IP address. Okay, so it is on my network at .83. And before I load that, which one is the Pi? This one's the Pi. I'm going to move this over to here. And let's go have a look at what is sitting at this IP address. Okay, we get a login. Like we said, I've already pulled in and deployed that Kerberos container as part of the build. It's turnkey, ready to run. There's nothing I need to even configure. And I don't know how well this is going to perform, but here's a stream.
I will bring you as well on this stream.
Yeah, so there's some latency only because of the fact that I have a webcam attached to a Pi over the network, back to me on the laptop, connected to StreamYard, then broadcast to YouTube. So I have about 7 steps in the middle here, but that's okay. What we can actually do is this. I have this camera pulling an image of me and sending it across the network like we were talking about. So I have a strange feeling, I hope, everyone say your prayers to the demo gods of choice, that when I come back to Datadog, oh yes, absolutely, I now have data coming in showing that I'm sending at approximately 140 kilobytes per second across the network. Whereas up until, this is the past 30 minutes, okay? Once I started that camera, and I'm gonna have a little bit of lag here, but once I started that camera, obviously I've now got network traffic coming off of this Pi, essentially 142K per second. And I see that the data is lagging a little bit, and that's fine. But let me come back over to here. And on this tab, I'm just going to click configuration. The reason I'm doing that is because it now gives you just a static image. The live stream coming off of that Pi has stopped. And if your prayers were successful, in a few minutes, we'll see that this comes back to pretty much negligible traffic being sent. That'll take a moment to catch up on the metrics. Actually, let's just switch it to like past.
That's really interesting because you even can measure if you have cellular connectivity, for example.
Yep, exactly that. So, perfect talking point there, Mark. You can measure your application's network, what do I want to call it? Throughput needs. That way you can then estimate and size the type of cellular plan you need if your IoT device is going to be sitting out in the wild off the grid of Wi-Fi or Ethernet. So the point there is, okay, 140K per second. Now look, this was a live video demonstration. Yeah, I'm not sure how many IoT projects, certainly edge AI projects will make use of live video analysis. Are those on cellular or are they on Wi-Fi? That you could use this data to make that cost analysis, quite honestly. At 140K per second, you can start to then calculate and do the math. Something like the Blues Wireless, the notebook or note card, I think it's called, has 500 megs. That's not going to do the job for this particular application. But that's, with this data, armed with this information, you can measure what does your application use. If that is small enough to get away with the Blues setup, you might save money by just going with their, I want to say that device is $49.99 US. I could be off on that. and the cellular is included. Now, on the other hand, we've tested in the past the Twilio SIM card. And the Twilio SIM card, the last time I checked, their current pricing rate was 10 cents per megabyte. Whether that is high, low, or somewhere in between is up to the customer to determine. I can say that the ease of use alone is probably worth the 10 cents per megabyte. I literally just plugged the thing in and it worked. You can't beat that. And it has global coverage. So, there's engineering resources to, compare and contrast there. But point being is you can begin to estimate your spend per device. If you know that it's 10 cents per meg, start to extrapolate this out. Is this information going to be broadcast 24/7? Or is it just, a quick burst to the cloud, capture your data, and, like in the case of a fin, the device it can be put to sleep until some set interval. So the point is you need to do your math, but you can use this to start to gauge your costs. All right. The other thing that we should have seen here is a little bit of, I guess it's a little tough to say.
Yeah, probably
during this period we had it running. So we had some increase in load. Not a whole lot, to be honest. So the impact really wasn't that. Oops, hold on, make that bigger. Our CPU spike really wasn't that much. That's a good thing. I mean, the Pi4 handled the job, no problem. It's got a quad-core A72 SoC on it. It's enough to do the job. Now, let's repeat this experiment on the NanoPi. I don't know what's going to happen. We're going to find out. I mean,
should I prepare this?
Yeah, keep that on standby. I don't know what's going to happen, but it's only one way to learn. It might handle it. It really, I don't know, but at least we'll be able to compare and contrast the results. So let's grab.
It's a bit unfair that you're using 1 gigabyte versus 4 gigabyte RAM.
Yeah, it's not. It's not a fair comparison. It's not the same performance level. Again, this is on purpose for the demonstration. But customers and IoT fleet owners, or even just home hackers, can use the same methodology to determine if they're having resource issues, or need to think about upgrading their hardware, or quite honestly, just to sort of get some information on their device health. All right, so this one is sitting on my network at .186. Let's grab that, come back over to Edge. Whoa, come back here, come back. And go to this instance of Kerberos and log into it. And all right, now I don't know, because of the latency, this might not make it through the stream all the way to YouTube and Twitch, but I can actually tell right away in looking at my view in my browser on my local LAN that this stream is not as smooth. I'm definitely at a lower FPS here, frames per second. And Kerberos doesn't tell me that information. That's fine. That's not the purpose of the utility anyway. But I can certainly see that it is not quite as smooth. I only left it running for a split second because I don't know how long it's going to live. In fact, that may actually, no, okay. It survived that quick test. All right. Let's take a peek at its health. It does look like it has survived. That's good. We can see the network. The results are lagging a little bit. Let's zoom in. We'll see the CPU workload spike. We'll see let's make that bigger. And let's come back out a little bit. Nah, not too bad, but this one is sitting somewhere at 40 to 50% CPU utilization. Let's turn it back on, actually. Let's see what happens. I'm going to let it run. I'm going to let it run. It might die. We'll see. Yeah, there, it's still there. All right, so we're going to let that run for a few more seconds. And actually, if I move, why can I not open a new window? All right, let's see if we can keep both active and see what happens. We might get some major lag in the Datadog updating now. We'll have to see.
Yeah, we have to understand as well that the Pi, it's sending the data to Datadog, so
exactly
it's having a hard time sending the to
so
Kerberos.
So this NanoPi is now going to probably struggle, I assume, to do both the Kerberos application with its live feed, as well as collecting the Datadog metrics and health and ship them up to Datadog to get rendered. So I have a strange feeling we're going to have some very serious lag here in just the collection itself, actually.
Yeah, you can see the lag.
Wait a minute, past 15 minutes.
So why?
Hold on. Yeah, so there goes the spike again. So it seems to be surviving, but I have a feeling we can kill it if we really want to. And we're going to do, we're going to do something. Oh, disk latency. So we definitely have some SD card thrashing going on that NanoPi. But again, just for purposes of understanding, let's do this. If it will, in fact, load this configuration, let's come over to the USB camera. And it's broadcasting at 640 by 480 across the network. What happens if we bump this up? We might actually need to perform this experiment on the Pi4 because this may, in fact, kill the NanoPi, but we'll give it a try. And then come back to the dashboard. And if everything goes according to plans, we should see that the increase in resolution will appropriately increase the network traffic that we are sending because we're taking a larger image and pushing it across the Wi-Fi. This might lag by a bit, but I hope if it doesn't actually just flat out kill the device, we should see this. If we were at 275-ish, hopefully we'll see this jump to about 400 or 500K per second. But again, it gives you the idea, and the theory and concept here is that you can tweak and tune your application and measure and monitor and view the impact. And sure enough, I don't know, we might have killed it. But the increase in the resolution, if this thing does in fact survive, would show somewhere in the 400 to 500K per range. We can try it on the, what time are we at? We have 10 minutes left. We can try that on the Pi4. It'll live. Let's come back over here. This is the Pi4. Let's change. Oh, it was only at 320 by 240. No wonder.
Oh, you were cheating.
Oh, I was cheating. Hold on a minute. I was doing some experimenting. No wonder it's not even breaking a sweat. Oh, come on. All right. Try that. Update. You know what? I wonder if I had to click update on this one. Did I not do that? Let's see if it even worked. Well, USB camera. No, it didn't even take. 1024 by 768. Confirm and select, and then hit update to confirm the configuration. All right, so the Pi4. Now, Pi4 broadcasting at 1024 by 768. Give it just a moment to collect some data. Then come back to Datadog. And go to past 15 minutes. Actually, we'll go to like past 5 minutes. And I'm hoping that we'll see a slight increase in the traffic. So I'm wondering if this is still lagging. I can't quite determine if it's still lagging, but let's come over. Oh yeah, we can see it on the NanoPi. That change must have actually taken effect, because at 320 by 240, we were roughly in the 200, or was that the 640 by 480? I can't even remember now. I've got so many values.
320. No?
Yeah. But we can see when we increased the resolution, it did take effect for a moment, and we were at 600K per second. So all said and done, the point here is you can use this information, kind of like we did say earlier, to then estimate and gauge your hardware and connectivity needs. I definitely see an increase in workload here. Oops, I shouldn't have done that. Leave it, go back like 30 minutes and make the load. And we can see which one are we on? Is this the NanoPi? Really starting to increase here. So
yeah, this is NanoPi. Yeah, the memory breakdown.
Yeah, the memory breakdown. Yeah, you can see we even took more memory once we bumped up that resolution. So now we're up to 648 in use. So point being, use this information to estimate how much compute you need. The Pi4 here, let's come back to it. You can see now Datadog has caught up. We're pushing about 400K per second at that increased resolution. And you can see the CPU, look at the CPU usage just on, this is a pretty dramatic spike there. I mean, it's not totally, what are we at? 50, maybe 60-ish. There you go, 48.07. There's still some room for additional compute. I don't know that I would go too much higher than this. You always want to leave, obviously, some wiggle room, but the point is you can see the impact visually. So we were successful. 6 minutes to spare.
And actually, can you introduce, sorry for interruption, but can you introduce events? Like, let's imagine that the Pi4 gets offline. Can I get an email, for example, from Datadog, things like that?
You can, in fact, do that. You can set up alerts to send notifications upon thresholds being reached, or and like you said, a device goes offline. I don't remember precisely where it's configured in here.
That's as well very handy, right?
Yeah. Oh, actually, here it is right here. Duh. It is events on the left-hand side. And I, over the past couple of days, have in fact triggered a few of these while I was setting up this demo for today. While I was getting this all prepared, I power cycled the devices, built the containers. I had them online, I had them offline. You can see actually, here's an alert that I have set up, a monitor that is the device online? If it goes offline, send me an email. Alert, host is down. Check the interweb connectivity on variable host name, and it gets sent to my email address.
Cool.
So I can literally pull the power on one of these. I don't know that I necessarily want to do that at the moment, but if the device drops offline, I get an email. Yep, absolutely.
That's interesting as well when you have a really big fleet of devices.
Yep.
Right, to have alerts like that. It's interesting.
So there you have it. there's the repo. Let's drop it back into chat. And I missed, let's see here. There we go. There it is. So you can use that as a getting started hop off point to measure your applications.
Absolutely. Questions. Very cool things. Thank you.
Yeah.
Thank you for
no problem.
checking what we do on Twitch. People on Twitch, it's
Twitch actually is working great. All right.
Exactly.
Good stuff. Good stuff there. Any other questions? Let me check back through. I don't see any that have
questions. David, do you know that we are hiring?
You know what? I do know that we are hiring, but I didn't check the posts this week, Mark, so I might need you to fill me in on if there's anything new there
with the community. Maybe someone from Twitch could be interested.
Absolutely.
Open positions at Balena. So actually, we have 3+1 open positions, right? We have the product engineer for Balena Etcher. So if you love Etcher, this is your opportunity to apply for that position. We are still looking for a security engineer and a front-end engineer as well.
Okay.
And I don't know if you want to get into the
and then you said
your own role position.
Yeah, you said 3+1. I can speak to that +1. The +1 is design your own role, which is exactly like it says. It's sort of an open call for folks to fill out that might not fit exactly into those other 3 spots that you mentioned there. But if there's, a certain set of IoT skills, engineering skills, cloud skills that
fleet
you've
operations.
got, fleet operation skills, even, over on the business side of the house, I don't know if there's anything specific that we're looking for, but the point being, if there's something that you could bring to the table, by all means, fill out that design your own role and it will get a look as well.
Absolutely. And what do we have for next week? I think that we still need to think what to do next week.
We need to figure something out. Let's ask the audience real quick.
Yeah. What do you want to see next week?
We have an opening next week. I might have something.
We have plenty of topics.
Yeah, I might have something lined up, but I don't want to spill the beans on it quite yet. I'd rather we see what the community has in mind. So let's give it a moment, see if any questions or comments come through, or ideas, I should say. If not, we've got plenty of topics that we can cover.
Absolutely. What else? I think we are good.
I think we're good. You know what? I'm going to put in one more blog post link. Thank you for grabbing the one earlier while I was data dogging. I have another blog post here, which essentially goes through some of the background of what we just talked about. It links, of course, to the same repo that we just showed, but it gives a little bit of a recap. So, if you don't want to sit through the full hour episode that we just showed, which is, in my mind, fantastic, but if you're more of the reading type, you can actually go check out that post, and it covers quite a bit of this as well.
Absolutely. I think it's very clear. I think getting this tool to understand what's if the hardware fits into the project and when you will grow as a fleet, to have this assurance with data that it will work and it will be stable, etc. And then when you have a fleet as well, to have a tool like that, I think that could be
when you've got lots of devices. Let's say you have 100 devices, 1,000 devices out in the field, and you start to experience an issue on 1 or 2 of them. You can drill into this data to get a little bit of understanding of what's going on. Now, wait a minute, 98 of my devices are performing just fine. but one or two of them are having some difficulties. Maybe this is the information you can start to pinpoint, is the SD card failing, or if it's offline and there's no data coming through, you can see, well, I guess it depends on how offline it is, but
Exactly.
you can check your connectivity, CPU load, so maybe the device got compromised in some way and it's mining Bitcoin, find out. But so, it's a very valuable tool once you've got lots and lots of devices to be able to monitor what's going on them.
Absolutely. So I think that was a great episode. Thanks, David.
Yeah.
No
problem at all.
Teaching me how to get use of Datadog.
All right.
See you next week.
All right. Bye, everyone. We'll close it out and see you next week.
Have a good day.
All right.
Bye,
Bye guys.